Okay, so today we're going to be talking about binary. So let's start with what a bit is. A bit stands for binary digit, and it can either be a 0 or 1. And you can think of it as like a light switch. So when the light switch is off, right, when it's flipped off, it's a 0. And when a light switch is flipped on, it's 1. So whenever you see a binary number, you can think of 0 as off and 1 as on. Binary has a base of 2, as in bi, right? So bicycle or bipedal. The notation for this is either going to be a subscript 2, which could be, for example, if we have the number 1010 in binary, it would have a subscript of 2, or it could have b before the number. So that could be binary 1010. And that b and 2, they both mean that the number is binary. Because you could also read this if it wasn't notified as binary, right? It could be 1010, right? So just to avoid that mistake, make sure you add the b or the 2. So looking at binary, every 1 that you see, it's going to be 2 to the power of the location of that 1 bit. Now, this sentence may be confusing, so let's do a quick detour and look at decimals. So decimals is something that we work with every single day of our lives since kindergarten, right? We're counting 1, 2, 3, 4, 5. So we subconsciously do 10 to the power of n with decimals, and we just don't realize it. So an easy example is 5, right? So we have the decimal value 5. This is the 0th position. And so that's going to be 10 to the 0th position, right? So 10 to the 0. And again, this is 10 to the n, right, which is right here. And n is the position. So position is n. And then down at the bottom, we're going to put it all together and say 10 to the 0 times whatever is in our top row. So 10 to the 0 times 5. And so that's going to be 1 times 5 equals 5. So let's do one more example in decimal, this time with 325. So 325, this is the 0th position, first and second. This is going to be 10 to the n, so 10 to the 0. It's going to be 10 to the n, which is 10 to the first. And this is going to be 10 to the second, right? So we're just looking at that n row. And then down at the bottom, we're going to put it all together. So 10 to the 0 times 5, 10 to the first times 2, and 10 squared times 3. Now, each column down here, we're going to add them, right? Okay, so 10 squared is 100. 100 times 3 is 300. So we've got 300. This 10 to the first is just 10. So 10 times 2 is 20. And then 10 0, that's just 1. So that's 5. And we add that all together and we get 325, right? So now that we've seen it in decimal, let's do it as binary. So here we have our number, binary, 1010. Let's put a little subscript 2 down there so we know it's binary. And when we read binary numbers, we're going to start from the right. So we're starting at the right bit here, and then we're going to move this way. And here we start counting at 0. So in our previous example, see here how we did the 0th bit, how I called it 0. That's because in binary, we start counting at 0. So if we do our binary example with 1 0 1 0, we can fill out the table again. So this is in the 0 position, first, second, third. And now we're going to do 2 to the n, so that's 2 to the 0, right? We're just looking at the n. So 2 to the first, 2 to the second, and 2 to the third. Putting it all together, that's going to be 2 to the 0 times the top row, so times 0. 2 to the first times 1. 2 squared times 0. And 2 cubed times 1. Now, putting that all together and remembering that we're adding each column, that's going to start with, let's start with our rightmost bit, our 0th bit. 2 to the 0 is what? 1. 1 times 0 is 0. So 2 to the first is 2. 2 times 1 is 2. 2 squared is 4. 4 times 0 is 0. And 2 cubed is 8. And 8 times 1 is 8. So we get a final answer of 10. So this in binary equals 10 as a decimal. Now you can also notice that this column here and this column here both ended up being 0. And that's because our light switch was turned off. So these were both zeros. So you can remember that later whenever you work on binary to decimal. You remember that zeros don't really count, but you do have to make sure that you are going by position. So even if you're not counting this 0, you're still counting the 0. So you need to start at 1. So now let's talk about range. So 1010, this is, how many bits is this, right? So a bit is either a 0 or 1. We count the total. So there's 4 bits here. And if you remember range from your previous math classes, range is like the any of the numbers that it could be with its number of digits. So here we have 4 bits. So we're seeing how many decimal numbers, how high of a decimal number can you make with 4 bits. So if we do this the long way, you can see that it can go from all zeros, which equals 0 in decimal, and it can go all the way to 4 ones. Now, what does this equal in decimal? If we want to do a really quick example again, that's going to be 2 to the 0 times 1, 2 to the first times 1, 2 squared times 1, and 2 cubed times 1. That's going to be 1 plus 2 plus 4 plus 8, and that equals 15. So our range is 0 to 15 for 4 bits. Now, there's got to be a faster way to do this, right? If we have to do this long brute force method, if we have 100 bits, that's going to take us forever. So there's got to be a faster way. We see the number 15. 15 might not tell you much right now, but if we notice that these are all powers of 2, what's the next power of 2? That's going to be 2 to the 4th, and that equals 16. And 16 is only one off from 15. So how can we make an equation out of this that holds true? That's going to be 2 to the n minus 1. And so n equals our number of bits, right? So here we were using 2 to the 4th, and where else did we have 4? 4 bits total, right? So 2 to the 4th, so 2 to the 4th is 16, and then you just subtract 1, and that equals 15, which is our range. So for binary, and right now we're doing unsigned. Unsigned means that you don't really take positive or negative into account. It's simply just the number, which will be, in this case, 15, right? So the range for 4 bits is 0 to 15. Cool. Okay, so one last example question is, if you are given 16 bits, what's the largest number that you can make? Now, if we remember our previous equation that we just created, 2 to the n minus 1. So that's going to be 2 to the n. What's n in this case? N is 16. So 2 to the 16th minus 1. That gives us a range of 0 to, and you can do this on your own time, but if you really want to know the super large number, that's going to be 6, 5, 5, 3, 6 minus 1. So the range is going to be 0 to 65,535. That's our range. Don't forget to subtract that 1. That's very important. All right, that is all.